Hey, let me talk to you about Chapter 1 and D.S. Malik. So the way how the custom book's laid out is Chapter 1 comes from D.S. Malik, and then Chapter 1A from Farrell, and 1B from Farrell, and Chapter 2, 3, 4 from Chapter 2 to Chapter 8. It's by D.S. Malik. Let me go back and talk to you about Chapter 1. The whole book, okay, from this here. You don't need for me to sit here and read this to you. What I would like for you to do is to read it. The way you study computer science is you got to read it several times, and then make. I like to study and make note cards and highlight and write in the book and all this stuff with it. But if you hold on a second, my computer's locked up on me. There we go. So if you go through here, read through the bold print first, the header, and anything that, like you said, you see here, history's good. Give you, read 2-3 pages at a time, put it down, get online, spend 5-10 minutes, come back, read it again. It takes from me when you start to read technical documents, you need to read about 3 times. Okay. Nobody is expected for you to read this one time and absorb. You must walk on water if you do. So, like anything, this is a technical document. So it does take time for you to absorb. You can't do this and cram this in one night, and I can tell you that. The other piece about programming is that you need to be able to just do practice pencil and paper. It's like studying for a math problem. You just have to understand how things work with it. Anything that is bold word like this, main memory, random access memory, is fair game. All right, it's a definition. So you're expected to know all the bold words, definitions. It's the first chapter, 2 chapters is very definition oriented. Design, know what analog, digital signals, and all that stuff. Bytes, gigabytes, terabyte. On the test question, I asked you what's a terabyte equivalent to. What's a gigabyte equivalent to? These two are them, kind of like the sweet spot right now, but what we're using right now with it. Understand that 1 byte equals 8 bits, and that's why you have different configuration the way it is with it. Again, I'm not reading this to you. It looks very, very boring. I want you to be able to go through and read it, several times and absorb it several times with it. So that's how you study computer science. What I like to get to in this, how I do things and teach things with it, is really to apply what you do with it. And I want to go over, besides, a lot of the tests come from the examples, questions coming from the example questions with it. So make sure you understand all the examples in here with it. If you have any question, like I said, email me. I'll be glad to answer any questions with it. But one of the things I want to talk to you about is is the first chapter. It talks to you about how to problem solve. And the key thing is that you break the task down to smaller step with it. So for example, if you take this first example, it asks you to write and design an algorithm to find the perimeter and area of a rectangle. Something very simple, perimeter and an area of rectangle. Something that we've done, find the base times the height, the length times the width, area with it, and the perimeter is just the formula 2 times the length plus the width. That's what we grew up with. That's how we went to algebra. And they give you step by step with this 1, 2, 3, 4 with this, and everybody's familiar, and it breaks it down to smaller tasks. Okay, so that's what programming is about. It's about pseudocode. It's about flow charts. It's about logic with it. One of the things I keep on telling my students is that for you to if you want to write a program to balance a checkbook, for example, you got to be able to do it pencil and paper. If you can't do it on pencil and paper and a calculator, then how are you supposed to program it to work? So that's the same analogy I like for you to understand is, if we design an algorithm to calculate the sales tax and the price of an item sold in a particular state, I hope you can figure out what is 8.25% tax of $1 is, and on a pencil and paper, or sort it out with it before you can actually write to a program with it. So that's what this is about. I mean, it's about the logic. They break it down getting the sales price. They break it down to get the luxury item and all the stuff with it. So I'm not going to walk you through this. What I would like to do is to take it directly to the end of the chapter with this and go over some of the exercise problems with you and some of the stuff that you're going to see coming across with it. So for example, this is page 24 in your DS Malik Chapter 1 with it. So make sure how I would study. I would actually know the quick review. All right, the quick review kind of tights up with it. A lot of times there's a lot of questions in the exam that you see. These quick reviews are true statement, and I would rewrite it to make it a false statement by just negating or changing one of the words, or just making it false with it. So make sure you read through the quick review. It's a really good review as well. Coming down here to the exercise with it, let me do a few of these with you, because I understand that part of your exercises that you do have as part of your homework with it. And the answer in the back of your book, it provides the odd answers, but like I said, I'll do some of this with you, and I'll give you 1 or 2 answers with it, but I'm not going to give you the whole thing. But I'll explain what they're going with this. So for example, 1A, it's a true-false questions with it. I don't have true-false, but the calculating device called the Pascaline could calculate sums up to 8 figures long. That is true. Okay, so B, all programs must be loaded into the CPU, which is the central processing unit, before they can actually execute. All the data can be loaded to the memory before it can be manipulated with this. So this is actually false. It's loaded into the RAM memory first, okay, before it's going to be executed, and then from the RAM memory it goes into the CPU. So this statement is false with it. Look at C. Main memory is an order sequence of cells, and each cell has a random memory in its main memory. Main memory is RAM. All right, is the order sequence. Well, order sequence is actually the program. So right there, it's already false already with it. So C is false as well. Just to give you a few of these things with it. So I asked you to do in the homework, I asked you to do the even numbers, 2, 4, so on, but I'll give you a few, okay? So which hardware component performs arithmetic and logical operation? If you remember, there's a picture in your book, way at the beginning of the Chapter 1. It's your CPU, all right? That's the one that has your arithmetic and logical operation. Now, there's something you have to understand in here, and be reading there. Your CPU cannot calculate remainders. All right. So one of the things that you're going to hear me come and talk to you about Chapter 2 is what's called mod. Mod is modulos. It calculates the remainder. I'll tell you why that is so important. How we do mods and moving towards your Chapter 8 to it when we talk about arrays and how we calculate columns and rows with it as well. So just to let you know, your CPU performs what's called arithmetic and also your logical operators. There's 2 sets of operators. One of the set of operators is logical. All right, so we're going to talk about some of the logical operators with it, and I want to talk about the other set in Chapter 4 and 5. Don't worry about that. So that's number 2. Number 3 says, which numbering system is used by a computer? Numbering system. Well, all computer uses what's called base 2, or what's called binary. You hear this thing called binary, 1s and 0s? Well, that's binary. It's an on, off, that type of stuff with it. So it's binary or base 2. Number 4, what is an object? What is an object program? So an object program is the equivalent machine language of a higher level programming language. So when you think of an object, I want you to think of things that actually it's a machine language program that you're writing, and this object that it's a higher level programming language like C++, yet you're programming, and it converts it to a lower level programming language. So it's an equivalent. The object is equivalent to kind of like this catalyst or this software that you're taking higher level programming, like English that we're speaking right now, and converting it to a machine language, which is what? Binary, base 2. So that's what an object program does. What is linking? Number 5, linking is a very important step with it. So when you program, let me do this. Let me pull up the Paint. I'm going to write in Paint with this. So I want you to think of this. When you write your source code, your CPP. Sorry, I'm doing this. So remember when you did your hello program, what you call it? Main, right? Sorry, I'm doing this on a mouse. So. Main, that's an N. Okay, so you did this in Visual Studio, and you're going to compile this. That's a plus sign. When you compile it in your Visual Studio, you're combining what's called the library file. So when you compile this thing, let's say you don't have any error. This is your compiler. All right, I'm going to say compiler. And your .lib is your library file. That's just what I'm trying to write. Well, you try to write with a mouse. Compiler, R, E, R. Okay. And ultimately, if you did this right, you should get what's called an executable.exe. And this executable is actually stored in what's called your debug directory. Okay, it creates it for you. Debug directory. And in this debug directory, it generates for you. You will find your executable. And when you click on that exe file, your executable, it actually interacts with what's called your DLL, dynamic link file. There are hundreds of these things, all right, that actually interact with your DLL. So it's like a big data hive with it. So we keep this. This is what we do. We keep this in a safe place. God, I hope nobody sees this. This is embarrassing. I have poor penmanship. Because this is where we keep it safe. We sell this. This is where the money is. Yeah. This is what we sell as the executable. Okay. Cha-ching. So we sell this part. So every time when a software updates, they have to update the main, which we call this as the source file. Okay, this is the source file. So if you understand this, you got pretty much how programming works with it. Now this compiler right now is what? It's your Visual Studio compiler. So this is what this is about with it. Cool? All right. So let me ditch this. This is embarrassing. And see where I'm at right now.